When you have perpendicular lines, you know that there's going to be right angles. When you have parallel lines, you can find angles that are congruent, like opposite interior or opposite exterior, corresponding angles, stuff like that. So this helps with proofs to know those. Bisects means it's exactly in half. Same with angle bisector, cuts the angle in half. Segment bisector cuts the segment in half. So we're going to use all of those things to do our proofs. So right here, when we know that BD is perpendicular to AC, we know that we're going to have a right angle at ADB. So that's going to be a right angle. All right angles are congruent, so you know that these two will be congruent. BD bisects AC, so you know these two will be congruent. And then we'll show this congruent by reflexive. So let's see, we'll use reflexive property. And then we have a side angle side. So we'll use side angle side to show that those two triangles are congruent. So let's go ahead and work on that. So we'll send these perpendicular. So now we're going to say that B, how about ADB, angle ADB, and can you say is a right angle? And that's definition of perpendicular. And then we're going to do angle CDB is a right angle. Same thing, definition of perpendicular. Wish we could put them both on the same line, but that's okay. Then we're going to say that they're congruent. Angle ADB is congruent to angle CDB because all right angles are congruent. Okay, we've got that. And then we're going to say AD is congruent to CD, segment. AD is congruent to segment DC. And that is definition of bisector or bisect. Let's see, definition segment bisector. Okay, so what do we have so far? Okay, we still need to do the reflexive property. So BD segment, how about DB is congruent to segment DB, and that's just going to be reflexive. Okay, so let's see, do we have everything? We have segment, we have the angles congruent, and we have this segment. Okay, so we're ready to say it's true and by the SAS. Nice. That was really fun. Okay, let's do another one. Okay, let's see what we got. So QR, of course, QR and SP are congruent. QR and SP are parallel. So if I put a little arrow like this, that means it's parallel. This is a transversal going through here. So alternate interior angles, we could use that one and that one are going to be congruent. So we're going to do alternate interior angles. Then we're going to use reflexive property. Okay, what do we have here? Let's look at this triangle. Side angle. Is there such a thing as side angle? Nope, we can't do that one. Okay, we don't want those angles. Let's do the other two interior angles. Let's do these ones. If we do that, I did it wrong. Wait. If we do that and this one, that and that, interior, alternate interior, this would be side angle side. Yes, okay, we could do that. Okay, so here we go. They're going to say, we know those are congruent. Okay, good. Let's go ahead and do PR is congruent to RP by the reflexive property. PR is congruent to RP. Remember the order that we want to do, and that is reflexive. Okay, then we're going to do the parallel thing. Wait, how come it didn't validate? Is it not going to? Okay, then I'm going to say these are parallel. That's given. Because they're parallel, we have angle. This one right here. PRQ is congruent to angle RPS. And that is alternate interior angles of congruent lines are congruent or whatever. We're just looking for alternate interior angles. Aha. If lines are parallel, then alternate interior angles are congruent. So we have the two sides, we have the angle. So now we're ready for the triangles congruent. And we just say for SAS. Nice. Proof is complete. Check it. It should be good. Yep. All right, let's do one more just for fun. So let's see what we have. Let's write down here. EG is perpendicular DF, so we know that's right and that's right. So they're going to be congruent. EG bisects angle DEF. Where's D? Ah, so these two angles are congruent. We know these sides are congruent. So we have angle, side angle. We're going to use reflexive, definition of bisector, definition of perpendicular, et cetera, et cetera. So we're just going to go like that. Send those in. Okay, we're going to put, let's see, DGE, angle DGE is a right angle. Can I say and? Oh, it's not going to let me. So we put is a right angle. Definition of perpendicular. And then we're going to have angle FGE is a right angle. And that's definition of perpendicular. But now, wait, where's definition of perpendicular? There it is. So now we're going to say that those two angles are congruent. DGE is congruent to angle FGE because all right angles are congruent. There we go. Okay, we got that. Then we're going to do segment. Take that off. How do I take that off? I guess I'll just backspace. Segment GE is congruent to segment GE because of reflexive. And then we're going to have these two angles right here. So angle DEG is going to be congruent to angle FEG. And that is because of definition of angle bisector. Angle bisector. Did I do that? Definition of angle bisector. Ah, right there. It says that the two angles will be congruent. So let's see, we have the angles, a side, another angle. So we can go ahead and prove by angle, side, angle that the two triangles are congruent. Okay, that's the end of the lesson.